In this video, we are going to learn about how to create a schematic symbol and PCB footprint for LM2596 3 ampere step-down switching voltage regulator. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. As always, this video is divided into 4 important parts. First one is understanding the datasheet by going through the datasheet of LM2596. Second step is creating a schematic symbol using the IEEE standards and understanding how to design it according to the user perspective. Third step is creating a PCB footprint by using the IPC standards and Cartesian geometry. Last but not the least, fourth step is to creating a component library by combining a schematic symbol and PCB footprint that we just now created. So let's get started. Now we are in front of a datasheet of LM2596. This particular datasheet is from onsemi, is a manufacturer of 3 ampere step-down switching voltage regulator. We can also refer a datasheet from various manufacturers based on your availability and materials that is available in your locality. Now, if you look at this particular datasheet, you can find very important information while you are using this IC for a design activity. Most important reason why this IC is being used in industry is for 3 ampere of constant current output if in case designed for constant current application. Or you can consider it for efficiency, because normal regular voltage regulators, which are so-called linear voltage regulators, will be having an efficiency which is less than 45 to 50% in normal condition. But this particular IC is having a capability of achieving an efficiency up to 75%, which is great in case of a normal power domain application. Now, considering all these points, we are heading towards the SMD version. Why? Because we want to explore how to design SMD footprints and all that thing. That's why we are using a double-decker package, which is so-called D2PAK or D2PAK. Now, this particular IC is having a 5 lids. That's why we are going to refer the schematic symbol for LM2596 with a 5 lids. And arrangement of those lids and arrangement of those pins are going to be as per the schematic diagram given in example section or a typical application section of this particular data sheet. Now, if you scroll a little bit down, you can see all the details required, electrical, mechanical, thermal or efficiency related details in this entire data sheet. But we are not going to dive deep into that because we are focusing on creating a component library. Now you can see that this is the mechanical information of this particular IC in a D2PAK or maybe double-decker package. So here you can see the body size and the lid pin size and also lid pitch. All the details are given. But most important thing is they have given us directly what is the mounting footprint or recommended mounting footprint of this particular IC. This is very important and very helpful for the designers to follow the standards as per the manufacturer. Otherwise, we assume some data and based on that we design it. However, now we have all this data information in front of us and all the details are straightforward, easily visible, easily computable, and we are going to use this particular information while designing a footprint. Now it is time to go towards the schematic symbol design using EasyEDA. Let's do that. Now I am in EasyEDA to start creating a schematic symbol using IEEE standards. First thing, I'll go to the file and create a new symbol application. Now here I'll place the connect points or the points where we connect the signals and start creating the schematic symbol as we always do for all the schematic design activity. Now you can see that I have completed creating a schematic symbol using EasyEDA with a user perspective in mind. So considering that we have arranged our input and enable pin on the one side and output and feedback pin on the other side. Why? Because whenever we want to turn on and turn off or control the power on and power off cycle of this particular regulator IC, then we should have an input pin or enable pin on the input side. That's why we have arranged the enable pin on the input side, wherein the feedback should be always close to output. Why? Because it is a feedback of output voltage, and ground is on the bottom side so that we can connect the ground symbol directly to the ground pin. Now it is time to head towards the creating a PCB footprint using IPC standard. So let's do that. For creating a PCB footprint, I'll go to the file and create a new footprint wizard. In this place, I'll be placing the pins as per the requirement and referring to this recommended footprint design from the datasheet. So let's start with the process. Alright, now you can see that I have completed creating a PCB footprint for D2PAK 5-pin IC. This particular design looks very good to me, but again, if you are creatively want to change anything, feel free to change that, but make sure that the pin number and Cartesian geometry will never change, because that is the standard. But what you can change is the representation of the border, or maybe top silk layer data, whatever I have drawn by using the arrow mark, or maybe writing a D2PAK 5-pin lead. All that thing you can modify as per your requirement. Now we are done with creating a PCB footprint as per IPC standards and Cartesian geometry. It's time for creating a component library by combining this particular footprint with a schematic symbol. So let's do that. To complete the process of creating a component library, I'll go to the schematic symbol that I have just now created and then click on the footprint option. Here I'll browse for D2PAK because that is what the package or the IC that I have designed, and in that I can see that there are two options visible to me because I have created a D2PAK 3-lid or 3-pin IC a long back, but right now I have created the 5-pin one. So I'll select that and click on update footprint. Now we are done with creating a component library for LM2596 with a schematic symbol and PCB footprint. Just in case if you wonder how it looks like when you are using it in a project work, then this is how it looks like. I have created a small dummy project here. I'll go to the library and I'll search for LM2596. In my case, it is visible in workspace because it is my library. In your case, probably it is visible in user contributed if you are searching for my library. Otherwise, if you have created by your own self, then you will be seeing it in your workspace as well. There I can see both options are visible. First one is the old one which I have designed long back, and the recent one is LM2596 with a D2PAK 5-pin lead. And you can see the schematic symbol and PCB footprint visible to us. If I click on place option, you can see that it is available for using for the design activity. And whenever I select that, you can also see that the footprint is also attached along with. This is how you can create a schematic symbol and PCB footprint, indeed a complete component library for 3 ampere switching voltage regulator LM2596. Super duper! I believe that you have enjoyed the entire process of creating a component library for LM2596. Consider subscribing to our channel Linked Frequency. It will be free for you, but it means a lot for us to grow in the technology community. Thank you so much for watching this video. See you again in the next one. Until then, tune yourself to make a difference.